If you are visiting our channel for the first time, please subscribe first to get the latest updates. Hello everyone. Today we are going to discuss the concept of differentiation in maths. It's a very important concept. Before understanding how to find the derivative of different types of function, you must know the concept of differentiation, that why it is basically required. So we will start with the concept. Keep one thing in mind, that differentiation is basically all about slope. It's all about slope. Now what is slope? Let's discuss the concept of slope in a way that you will easily understand the concept of differentiation from this. So first of all, we will start with the slope. Basically, slope is defined as change in y divided by change in x. Now what does it mean? We will discuss it shortly. Currently you just know that this is basically the slope. So we can also write it as delta y over delta x. Now what is this delta? Delta basically represents the change. This is basically the mathematical representation of the slope. Now delta y is basically change, so we can say that it is equal to y2 minus y1 divided by x2 minus x1. This means the slope of 2 points. So we need 2 points in order to find the slope. So it is basically generally also called as rise over run. So this is just the mathematical representation of a slope. Let's see how you understand and how you can understand its concept graphically. So let's discuss this concept by means of the graph. So graph is here where you have, this is y-axis and this is x-axis. Let's discuss the general concept of the slope. Then we move towards the differentiation. This is the line, and just imagine that you are moving on this line. First you were at this place. We will take this as point 1. Then after moving from here, you reached at this point. This is another point. Now keep this in mind, that the slope is basically only when you are moving at a steep place, or you are climbing, or you are in a way that you are not moving in a straight line horizontally. There must be a change in x-axis on the x-axis as well as on the y-axis. So here how you will see that there is a change on the x as well as the y-axis. Let's see. So at this point you were at x1, and when you move ahead you reach at a point that is basically x2. This is the change in x-axis. It means you have traveled a distance on the x-axis or horizontally. But what about the vertical distance? So vertically you were at point y1 initially, and after you moved a bit you reached at a point that is y2. So it means you have covered a distance in the horizontal as well as in the vertical position. It means you definitely have a slope at this point. So from here till here is the delta x, that is the change in the value of x, and from here till here is the delta y, that is the change in the value of y. So from these two things you can find the slope. So what we deduce from this graph, let's write it down. First thing that we have seen here, this is basically the slope between 2 points. Before understanding the concept of differentiation, you must have the clear concept of the slope. Then you will be able to easily understand the differentiation concept. And another thing is, this is a straight line on the graph. This is a straight line. Now, what is the use of this straight line? Why do I have used the straight line here? Here, the meaning of straight line here is rate of change will be constant. Rate of change is constant. That is, the slope between any 2 points on this line will be the same. Either you took the slope between this point or this point, or this point or this point, or this point or another point here, any 2 points, you will find the same slope because the line is straight and the change in x and y is the same. So it means that it means on a straight line that x is changing y is changing corresponding to x in the same manner. So another thing we have deduced from here is whatever 2 points you take, slope will be same. So this was the basic concept of the slope. This was about the slope of a straight line. But what if you came across the function of which the graph is not a straight line but it will be a curve? Then how you will be able to find the slope in such a situation, because it was only the case in the of a straight line when the slope is same, where slope is same and you can take any point and the slope you will find, and the slope will be same. But in case of the curved line, it will not be the case. Here is the question that what if line is not straight? So here comes the concept of differentiation. So let's understand this concept as this is the graph like this. Now this is the graph, or this is basically f of x. Now it is clear from here that this is not a straight line, and we cannot say that the slope of this line will be the same at all points as in case of the straight line. Now what if we take the 2 points and find the slope of these 2 points? Like if we take these 2 points or another 2 points or any 2 points on the curve, then it will not be the case that you will get the same slope. So in such a case, what we need? We will need an instantaneous rate of change at a point of a curve that is constantly changing. Instantaneous rate of change at a point of a curve that is constantly changing. So if we find the instantaneous rate of change, then after that you will be able to find the slope at any point of the curve. So what is basically the instantaneous rate of change? It's basically the change at one single point, or at an instant, or at a point right at that time. So basically we can say that if I find slope at this point, or if I find slope at this point, it will be the instantaneous rate of change at a point. So in such a case, what do we need? We basically need to basically draw a tangent line to the curve in order to find the slope at that point. So for that purpose, we will draw a tangent. So if you want the instantaneous rate of change at this point, then we need to draw a tangent to this curve, and then the slope of the tangent will be the instantaneous rate of change at that point. So we can say that slope of tangent is equals to the instantaneous rate of change at that point. So we need to find the slope of the tangent. So here comes the concept of the differentiation. So slope of the tangent line is basically slope of tangent line is defined as dy by dx. Basically differentiation deals with the small differences. For example, if I have taken this point, then it means that there is a small change near to this with which we are comparing, and we are basically evaluating the slope at this point. If I take any point on this curve as if it will be here, if I move near to this point, then if I move more nearer to this point, and if I move nearer to this point at a place where the distance between them or the difference between them approaches to 0. Then we can easily find the slope. So let's find, or you can say let's find a derivative or the difference or derivative here. Let's see how you can find. So we will find the slope between this point and the point that is near to it in a way that the x approaches to 0. So we will write as, so we have to find the slope of this tangent line. Let's see how we can find, as we have seen that for this point, for the point at which we have to find the instantaneous rate of change, we will say that x changes from x to delta x, and y changes from, y is basically f of x, so it changes from f of x to f of x plus delta x, where keep this in mind that the distance between the 2 points will be like where delta x approaches to 0, as we have to find the instantaneous rate of change. So we need not the 2 points but the points in a way that the distance between them approaches to 0. Hence, if we put these values here, then we will get the slope as slope is equals to del y over del x is equals to f of x plus del x minus f of x divided by delta x. Now keep this in mind that this delta is basically for change, and dy by dx is the representation of the differentiation or the derivative. So I have to put the limit del x approaches to 0 here as well. This is very important as we are looking for the instantaneous rate of change. So f of x plus del x minus f of x divided by delta x. Now this is basically the slope of the tangent line. So we can also write it as slope is equals to, we have written before, this is delta y over delta x, that is equals to limit of delta x approaches to 0 and f of x plus delta x minus f of x divided by delta x. Now this is basically the slope of the tangent. That is basic. Slope of the tangent is the derivative of the given function. So it can be written as dy by dx. That can also be written as f dash of x equals to limit of del x approaches to 0 of x f of x plus del x minus f of x divided by del x. So here the thing to be noted is this is the basically notation of Leibniz, basically called the Leibniz notation. Leibniz notation of derivative, of representing the derivative, that is dy by dx, and this is the Lagrange notation of representing the derivative. So these are the two notations. You can use any of them while finding the derivative, and in the next few lectures we will see that this formula basically used to find the derivative of function. So here one more thing is, at some places this delta x is also referred to as like this in order to show the small value. So you can also write del x or delta x, it doesn't mean, but your main concept is the instantaneous rate of change, to find the instantaneous rate of change. And one thing you have to keep in mind is process of finding the derivative is called differentiation. Thank you. Thank you for watching. If you like this video, please don't forget to subscribe our channel math.com for more updates. Thank you.